Hello, world, and welcome to Code or Not to Code. I'm Millie Eva, and as always, I'm super happy to be here tonight. And I'm here with Stefan. How are you doing, Stefan?
As good as it can be. Internet service providers have conglomerated. Is this a word? They have not blessed us with grace, but we find our way around.
We find our way. We're powering through. No worries. Yes, first of all, apologies for the delay. We were planning to have the amazing Stuart Lang join us today and talk about the new features in C# 13 and .NET 9. But unfortunately, due to some technical difficulties that we unfortunately could not resolve within the last hour, he was not able to make it. But do not worry. He promised to join us in the future. So we'll definitely have a follow-up there. But okay.
In German we say aufgehoben, aufgeschoben, nicht aufgehoben.
Your dose of daily German sayings, which means, what does it mean? It means what does it mean? If it's
postponed, not cancelled.
Yeah, postponed, not cancelled. Exactly.
It sounds similar in German, so there's a bit of a wordplay.
Yeah. A rhyme, yeah, that's nice. Daily dose of German. But yeah, if you're new to the show, just a quick introduction to anybody who's here for the first time. Stefan and I meet every other week, and we work on our .NET tool. So Stefan has a lot more experience than me. He's one of those .NET wizards, and his job is to make sure that we actually get some work done during the streams. I have less experience. I'm here to have fun and learn something, and also ask all the stupid questions. So whether you're new like me or like, I was going to call you a senior, but I always feel like that makes you sound really old, more experienced. I'm sure there'll be something in store for you today, something to learn, something to pick up. Because today we had a little bit of a pivot. So this is something that we wanted to do for a while, actually. But we were planning to do a little bit later. But you get it today. It's a really great topic. Should we switch to it? Because it's also got to do a little bit with C# 13. I don't know if you're regular on the show, you might remember that last year we had some really cool. I skipped it, didn't I? Because I wanted to ask you something else.
Maybe
Good stuff.
Let's go. Yeah.
I wanted to ask you something because we were talking about what?
Let's come to that. Yeah, it's a bit of an improvised session. Let's welcome all our viewers. Thank you, Eric, for holding on, for waiting. So, what's the word? Patiently.
Yes.
Toast and Twinning is back with an even more burnt toast.
Oh my goodness.
Freezing Six is back. So good to see you again.
Hello, welcome.
And your salty devil.
Perfect. Oh, it's a full house today. Welcome, everybody.
Well, I'm wearing glasses, but yeah, you don't, do you?
Oh my goodness. Yes, I love that joke.
Do you have contacts? Maybe do they count?
No. I see very sharp, just by nature. I was just born to see sharp.
You have native capacity. Ooh,
yes.
Nice.
Yeah, it's one of my few gifts in life.
You wanted to ask me about
because I can see. Yes. Well, first of all, I can see. I can see sharp, but apparently I can't read. Okay. Update conference. Yes, because you went to a conference, didn't you?
Mm-hmm. Yes, that was last week, and I've also met amazing people. I have met Dennis Doman, who has been on the show a couple of months ago, where we did a deep dive into fluent assertion and actually took also a look behind the scenes and how we can use it to extend it. And we extend fluent assertions in our tool, and I'm already also at work using already injected some fluent assertions, custom assertions here and there. And also, I have met the C# compiler lead developer from Microsoft, Jared Parsons, and I asked him a few questions about the topic we are tackling today. We talk about the new version or the next iteration of Interceptors, and I have some info that I would like to share with every one of you.
Awesome. So that sounds like great fun, because you go to conferences a lot, don't you? I feel like we've often been announcing it here. What do you like best about like actually being there in person? And is it like different than maybe like watching something or like attending, like virtually?
Meeting people, both speakers and attendees in person, and having a chat with them about stuff of C#, of .NET, but also going dramatically off topic sometimes.
Is it like different to sort of like have a talk in front of like a live audience?
It is. Well, on stream we do get feedback via the text messages. In a more live audience, you get like immediate feedback when, for example, people are like nodding or maybe falling asleep. It's
It makes all the difference. Oh my goodness.
I once there was in a Tekorama that's in a cinema. I put one to sleep. Yes, I blame the comfy chairs though.
Did you? Did you? How did you notice that he was really asleep though? Like, did you like?
It was visible that.
It was
or
very
maybe,
visible.
or maybe just staring at the floor, not moving. Could also be. Maybe focus mode. Maybe I'm
focus mode.
Maybe focus mode was engaged.
Could be. Well, that's awesome. I'm so glad you had a good time. And whenever you tell me about those conferences, I think they always really sound cool. And are they the videos like available online? Are we able to see your talk? Because you also
they are indeed.
session, right?
But they are not publicly available. You can get. You can go. I think it's now.updateconference.net. Yes. So on the now.updateconference.net portal, you get access to all that the team behind the update conferences. They, for example, also do stuff about Power Platform, but there's also a conference about .NET performance.
Yep.
You can get access to these events online and could watch those videos. Yeah.
Awesome. That sounds really cool. And yeah, if you're interested in watching one of the episodes, the previous episodes we did with Dennis about Fluent Assertions, you can head to our social media accounts, to YouTube's, and rewatch all of the episodes. And there's another thing that I did not see sharp when you first showed the screen. It's because we got a new entry there. We got a new social media that I actually haven't really been on much, but we're now also on Blue Sky. So if you're on Blue Sky, please give us a follow to keep up to date. As you can see, we sometimes have very last minute changes, and you would not want to miss them. So give us a follow on all the social medias, because we'll let you know on at least one of them.
Well, we definitely, as soon as we made a new date with Internet this time with Stuart to chat about the changes in .NET and C# 13, we will announce them via all of socials. But now let's give a test to Blue Sky. Let's see if it works. We are back exploring the new Roslyn Interceptors V1. Let's see if that works. It would be cool if it wouldn't. And cool.
Yeah.
Well, it's not the first
post.
No, it's not. I already did a Hello World, I'm afraid.
Oh, okay. Second post. It's kind of my first post. I've never posted anything on there. But yeah, it looks cool.
The first meaningful post, definitely.
The first meaningful post. Awesome. All right, but now let's dive into the subject, right?
The trivia, yes.
Oh gosh.
it is an ad hoc. It's been fun.
I'm struggling today. Start into the trivia.
Well, this may be our last our last trivia section, because next time when we have Stuart on the show, we'll dive straight into, because we want to utilize all the 2 hours we have to explore all the .NETs 9s and all the C# 13s. And perhaps next year, we also already talked about it, maybe do a more dedicated format on smaller, bite-sized, shorter, videos. 5 to 10 minutes videos, where we tackle one C# or one .NET topic at a time. But maybe we continue those also on this show. Let's see how this turns out. But since this show today is quite exceptional, let's talk about exceptions. Indeed.
that was good.
So let's
exceptional evening. Yes.
Well, first of all, we're using sharplab.io, which is dramatically amazing. We can run code, we can decompile and code to get rid of syntactic sugar. We can get a look of the syntax tree representation, how Roslyn sees our code, which we will be needing later. But it's very cool to just run smaller portions of code. Let's say we have our static method here. And our static method, well, maybe has not been implemented in the first place. Throw new not implemented exception. And this problem still exists. Implemented exception.
No autocomplete or what?
No, when I do autocomplete, then it resets everything. Yeah.
Oh, okay.
And so currently, yes, we call, maybe let's do a hello interceptors here. Woo. And when we call this method, and this method always throws, well, this method throws. And we do get the call stack. Well, we see there is some generated code inside. Maybe let's put it into a method, static into a class, our static class, which has our static method. And we invoke it, our static class, not our static method. And it's not accessible because per default, members are private, so we couldn't see them. Make it internal so we can see them. And we get in the call stack of the, is it stack trace or call stack? I always forget. This is the thing that I'm always mixing up.
I'm really the wrong person to ask. I kind of. What is the difference? What is the difference?
One is at runtime. One is at diagnostic time. So one is if you attach a debugger and maybe hit a breakpoint.
Yep.
At the time where this breakpoint is at the line of execution, that's one thing. The other thing is at once something has happened and once it has been recorded, like for an exception, it will be recorded. So I think it should be exception. This is the thing, auto formats and then removes everything.
Since when is that happening?
Sometimes not.
Happening. Okay.
Stack trace. There we go.
Okay.
Excuse me.
There we go. Today is a day full of exceptional behavior.
Oh yes, indeed.
Stack trace. Okay, stack trace.
Stack trace. That's the recorded one. It's on an exception, or when you put it into some logs, you have the stack trace. If we are on runtime and we take a look we do a breakpoint and we see where this current execution context is then the call stack. But yeah, we see here the recorded stack trace, and we see where we originally come from. So this exception comes from happens in our static method that was invoked here. We see a bit of more code. I think this is how SharpLab is invoking this code here. So let's ignore that. Maybe it could also be if we are in ASP.NET Core and this is our request handler, then we do see some ASP.NET Core before. So whatever is calling this code is before, and then we are in our generated program main because we are executable. There always is a main. The compiler is generating this main method for us. We're using top level statements here, so we don't need to write a main method. And our static class, our static method invocation. Now what we could do is we could catch this exception. We could do a try and catch the exception. Usually you would never call not implemented exceptions because you really should you really should not call a method that's not implemented. Maybe let's do something more sensible.
Don't tell me what to do. I can call whatever I want.
Invalid operation. This is the thing. When I autocomplete, then it all goes away.
Yeah.
No, I need to type without autocompletion. Operation exception. And maybe let's call an invalid operation exception.
Okay.
And maybe we want to log it. Console.byteline. We are simulating some logging now. Usually we would use some logger that is provided in the ASP.NET framework or in our console application, depending.
Yep.
White line. Let's maybe log the message. Oi, sorry for that. Let's log the message. Maybe let's add a message, our message.
Nice.
So we log our, let's call it our error message. So we have our error message. We catch the exception. We don't rethrow. Therefore, we then go on and execute the rest of the program. But what if in our case, we would like to catch the exception, but then want to rethrow it? So basically, well, having something of an interceptor. We want to, at some portion, we want to intercept this exception, but then still let it bubble up to the caller. And this should be done via the throw keyword. What we could also do is basically throw this instance of the exception again. And this may be a mistake, because every time we throw an instance of an exception, like here, this is throwing an instance of an exception, just like here. We could also form this differently. We could throw E here and do a var E equals to new. And, oops, one new does suffice. And whenever an instance of an exception is thrown, this is where the call stack will be recorded and put on the exception. When we do that here, we are resetting the call stack that was recorded earlier down there, and resetting it to the call stack here. So we are losing information. And we see that we no longer have the information where this exception originally was thrown. We lose the information that this was thrown in our static class, our static method, because we reset the call stack here. If we would do a proper rethrow, we just write throw, which is now rethrowing this exception without resetting the call stack. So we still have the information about where it originally resided, the exception occurred. So we don't lose any information here.
Okay.
There is another pattern. We could throw a new exception. Let's do another invalid operation exception. Or maybe let's throw a different exception. Let's throw a, I can't, it doesn't make too much sense, but I'm throwing a not implemented exception here.
Okay.
It doesn't make any sense, but maybe you have a more specialized, I don't want to implement now my custom exception. Maybe we have a more specialized exception. And usually exceptions may have an inner exception. So I guess we need to add some string here. It depends on some overloads. Usually you can have a new message. And then as a second parameter, this is usually an exception may also take another exception, because interceptions have a property called inner exception.
That's funny.
This is when exception. In this case, in our case here, this will be null because we don't have any inner exception thrown here. So this will be null. But now from this new exception that we throw, the inner exception will be now this exception that we captured here, that we caught here. And now this inner exception, in this case, this inner exception would still have the full call stack. We actually see this now when we rethrow this exception. We see, hey, via this arrows, you see the inner exception. And here's now our new message. This is our not implemented exception that we throw here.
Yes.
Which is thrown at main We are just for it in this generated main method, but it has an inner exception that has our original, sorry, I pressed F1, that has our original, our message, but also the original call stack that contains the information where this was thrown. So maybe you wanna, you could, what you could technically do here is something like you catch a system exception and then map it to a domain exception. So a custom exception in your application that maybe then later on is translated to an ASP.NET Core HTTP request status code, response status code, something like that.
Yeah.
So this would be another pattern, how to properly rethrow. There's a third pattern to rethrow. There is a type called...
Wait, that's the fourth one, isn't it?
That's the fourth one. So we can...
Well, the fourth...
Oh, yeah, actually, yes. So we can properly...
But one of them is not good.
And properly rethrow, we can rethrow a new instance, resetting the call stack. Yeah, that's not good. We could wrap M, and we could use the type called exception dispatch info. With with exception dispatch info, we can capture an exception at one place and then properly rethrow it at a different place. So auto completion is now, I think we need system. Does this work? Okay, yes. This type is in system runtime exception services.
Yep.
I think this is the only type that exists in runtime.exceptions. Oh no, there is two more types. It's a rather small namespace. And in there, we could, for example, capture an exception. We now get an instance of this info type. Let's comment the other stuff out. One assignment suffices. And then we can use this to throw, I should have not done that, to throw this exception. Need a semicolon here. And now we still see that the call stack is preserved. This is not, when you throw something via this dispatch info, you do not reset the call stack. This is something, for example, you could maybe capture this in one place, store this in a field or anywhere, and then at some point rethrow it if you'd like. There is also, if you want to do this in one go, and if you don't really want to store that info and store this to a field or a property or somewhere else, there is also a static method called throw. So we could also throw it like such, which is basically the equivalent to just saying throw. Both do the same thing. This is, I think, not sure if this is a little bit more expensive than just a throw. I'm not too much sure about the runtime differences, but the effective differences that we see is we still have the original exception with the original stack trace.
Okay, that's awesome. All right.
And yeah, that's about dealing with exceptional behavior properly. In the meantime, Vasi has joined. Thank you very much for joining.
Hello, Vasi.
Following the chat, Vasi asked if Toast is properly trained yet. Not yet.
Judging from the picture. There's room for improvement, but we're getting there. Baby steps.
Perhaps someday. Yeah, it's not. Maybe at one point in time we have a properly unburnt, not non-cancer causing toast. Now I want to eat toast. Damn it.
I know.
Cool.
Awesome. So that's the trivia section of the day, I guess.
Yes.
We can head. And now what I wanted to say, but while we're back here, if you go on our YouTube channel, you go back to last year's episode. We actually had 2 really cool episodes on interceptors back then. They were super experimental in C#12. But we still played around with them, and we created. So we wanted to kind of make them visible. So that's what we kind of built into our tool then. Oh, it's 3 episodes, is it? Wow.
Yeah, I forgot that we did 3.
Yeah, I thought it was 2, I remember.
One episode we did with, maybe let's tune in. Let's mute
Oh my
the
goodness,
first
no.
episode
This is
about this
scary.
episode we did with Jason Bock,
Oh,
who helped
I
us a
still have a
lot
different
to.
setup.
Oh yes, yes.
So many plans. I love
That's
it.
the other. Yes. For me, nothing really has changed. No. Well, I'm wearing a slightly different pullover. No, I see. And Jason gave us an amazing intro of how interceptors work and how we then implement them into our tool, because at that time tooling wasn't quite ready yet to visualize interceptors, and this is then what our tool should step in. In the meantime, Wido is now showing interceptors. I don't think Visual Studio is visualizing them yet. Also, interceptors have changed quite a bit since the last year. And this is now what we would like to do to update our tool to use the newest interception technique.
Nice. Sounds good. And before we start, this is going to be one of those episodes where the word interception or interceptor or where this word comes is going to be, we're going to use this word a lot in various different forms. So just before, when we were sort of preparing for this episode, I already got confused. So this is one of those episodes where you really have to focus. Otherwise, you're going to lose us completely. I'm probably going to lose Stefan a couple of times. So
while I will lose myself, I suppose.
I also lost myself. I thought I got it, and then I tried to sort of explain it to you what I thought I understood, and you were like, "No, you're using, completely different things." But it's gonna be fun though.
Maybe let's take a brief look at how interceptors used to be.
Yes.
We have, and still are. I think that the current way that's still compatible, or the old way that was experimental in .NET 8. Still, I think it still works. I think at some point this will be removed, or maybe it has been removed already. I haven't tested that yet, actually. Bit of an impromptu episode. But sooner or later, the old way will be deprecated and will not work anymore. It won't be then supported by newer versions of the SDK or by the C# compiler. We built an interceptor locator.
Yes.
Maybe let's take a look at our CLI tests, of our integration tests, while also zooming in. We usually have 175, don't we?
Yep.
And what it does is we have here, let's find the project. We actually have here a little interceptor where this is actually coming from a NuGet package. We have a test for that, but we also have a test where we build our own interceptor. I'm trying to find that now. Where do we add somewhere? That's not in the CLI test. Sorry, that's in the. Jumping to that later. So basically, we integrate an interceptor. Well,
Yes.
actually, we integrate a generator, because interceptors are really meant to be source generated by a generator. They are not really meant to be written by ourselves.
Yep.
And what this generator is doing, it's providing a more special case implementation of this enum.isDefined and enum.getName methods. Now, when our input to this project is here an invocation to enum.isDefined, that's in the system namespace on the type enum, there is an isDefined, which basically, let's briefly jump to SharpLab to show that feature. What it more or less does, let's say we have an enum, maybe we have the string comparison enum, comparison enum. For example, with string comparison, we can do a string comparison that's based on the current culture, on the invariant culture, or there is also ordinal comparison, which is really on a byte level of the characters. And let's also say, let's do ordinal, and we also want to ignore the case. So a lowercase character equals to the uppercase character. And maybe we can now say enum.getName. to get the name of that. So we basically, get here the same thing.
Nice.
And enum.getName under the hood, well, now .NET 8 already, and I can imagine .NET 9 maybe even so, was already really fast. But this enum.getName, even though it's super fast, it is working for each and every enum on this planet.
Okay.
What if we were generating a very special case implementation of this enum.getName that only works for this enum and no enum else? It could be ever so slightly faster.
Yeah.
It then only works for this enum, but a little bit faster. Or also like the same with the isDefined method, where we can ask, is this enum really defined? Because what we could do is we could cast, because an enum under the hood basically is an integer.
Yep.
If we would cast an integral value, if we would cast, for example, 10 to string comparison, now 10 is not defined. On string comparison, we only define from 0 to 5, which are those 6 values, where 6 is no longer defined, or the integral representation of string comparison. I guess we could take a look at the source code to make this a little bit more apparent. When we come to source.net, I love saying we see here enum. It doesn't say anything here, which means per default it represents an integer, so an int32 value. So this enum could assume values between -2 billion and +2 billion something. And the values 0 to 5 are defined. But negative values and the values between 6 and 2 billion something, or int.max value, are not defined. And this is now where this behavior comes from. So if we were to cast this integral value to this enum, this definitely is not defined. And again, the isDefined works with every enum on this planet, and the .NET managed it to be super fast. It's like nanoseconds something. But what if we were to generate a version that only works for this enum and no enum else? It would be ever so slightly, barely measurably faster. And this is what this generator does. And this generator now creates a new method, this very special case, enum.isDefined method, that only works for this enum and no other enum on this planet. And maybe we should say in the ecosystem. That sounds more fancy. But now we actually call enum.isDefined and not this new generated method. So what we can have is an interceptor that intercepts this call and reroutes it to the generated version of it. And our interceptor locator is now detecting this, that this call is intercepted. Actually, we have 2 calls intercepted. We have here the enum isDefined intercepted, and the enum.getName is also intercepted, because those generated intercepts them both. And then what our CLI tool then does, well, first of all, it warns that they're currently an experimental feature. This is something that we could now remove when we know we deal with the new version of interceptors.
Nice.
And we need to change now to this new programming model of how interceptors now work. But what we see here is that our tool is then listing the interceptors. So in this mynum.cs, which is this our very source file, we have 2 interceptors, 1 and 2. Or actually, we don't have 2 interceptors, but we have 2 interceptions. Now, now we come to using the correct term, and I am messing up. I'm failing myself. And the system.enum isDefined is intercepted at this location, line 9, character 18, which is here. Well, 1, 2, 3, 4, 5, 6, 7, 8, 9, line 9, and we would now count as characters to here. Character 18, and we also list the interceptor that is intercepting these calls, and this is now a generated one, flash over generated enum interceptor, and this is what we see, that this is a non-generic version of this bool returning method that only works for this single enum.
Nice.
And the same with the get name as well. And here we see the intercepted calls. But this programming model has changed a little, and this is what we need to change in our code. How the programming model
Alright.
looked earlier, let's go into the other interceptor tests that we have. They are not on our unit test interceptors, where we actually create our own interceptor.
Yes.
And we do that by, well, first of all, we need to, I just zoom in a little more that I don't need to do this zoom in, zoom out all over again. We first need to emit, because this attribute does not exist in the BCL just yet. So we need to have this attribute emitted in this current assembly. And the source generator does this too, or could do this too. This is the intercept location attribute that is in a runtime system runtime compiler services namespace. And it needs a constructor that takes a string and 2 ints, where we have the file path of the interception and the line and column of the interception. Where we go back to our example, it would be we want to intercept my enum.cs, the file path on line 9 on character 18. This is how interceptors used to work. And then we create our interceptor, and this interceptor is now currently only methods are allowed to be interceptors, and only methods can be intercepted. And also only ordinal methods can be intercepted. So currently we cannot intercept constructor invocations, for example. Only good old methods can be intercepted. And we say we want to reroute calls that originate from callsite.cs line 10, character 21. So that originate from callsite.cs. I forgot the line number, but it's basically here, line 21. I made a comment here. So if we were to count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, line 10, and we would now count 21 characters and would land exactly here. So between the dot and the foo. So we are intercepting this method invocation and not binding it to the originally defined method foo here. So it's no longer this method called. If the interceptor wasn't in place, this would be called. But since the interceptor is in place, it does a little bit of a sleight of hand and then reroutes the call to this method. We see that this method the interceptor must have a compatible signature. There's no arguments, returns void, just as the intercepted method. And if we had arguments, because we also intercept these 2 method calls, they are originally void returning methods that take a string. And we are intercepting these, also rerouting them to this interceptor. We see here those the intercepted location. And rerouting is to this method with a compatible signature. And no longer the method that the user wrote, but now the method that a source generator is invoking with interceptors is now called at runtime.
I have a question that I knew the answer to before, but I kind of forgot, or maybe I confused myself in the process of going through all of that. But thank you for explaining again. Actually, it was really useful. But like, okay, so we get to this method that has an interceptor, which is then being rerouted, right, to the other method, right? The method is executed, and then what happens? Is the original method skipped, or is it?
Yes.
Is it doing both?
Yes. No, it's not doing both. Without an intercept or per default, how the compiler works, there is a binding phase where it tries to bind this method invocation to the correct method. And in this case, it will bind to here. But now with interceptors in place, there is a phase of the compiler where it also looks, are these calls intercepted? And then no longer binds to the original invocation, to the statically typed invocated method, but to the one that is intercepted. So it's now the other method is being called. This one is not called. So after this method is concluded, we just go on. Well, we have again an intercepted call. So the interceptor is called. We have another intercepted method. So the interceptor is called. This one is not intercepted. So they are now called. This one is not intercepted. So we actually then call this method.
Okay. So I guess, so I'm a little, okay. But so why would you not just, if the method is not called at all, why would you not just replace the method? Why would you intercept and reroute it to optimize in case for someone else, more or less, right?
Well, if we have a generator, because maybe at the time we don't really know that this method exists. Well, maybe I just if we come back to like this method, I just want to write some code, or maybe I already have existing code.
Yeah.
But now I want to plug in a generator that creates interceptors and just changes everything. And I don't need to change my original code. And basically I plug in this generator that creates interceptors. Now the interceptors, they should do the same thing as the intercepted method does. They shouldn't change any behavior. This would be weird. It's not what I would expect. But it should do it more efficiently.
Yeah.
Also, a common use case, we also have a test for that, is for native AOT.
Yes.
Do we actually have a test for that? Yes, we have here, because what we do, we create here a new ASP.NET Core template. And ASP.NET Core with minimal APIs, they use a specific programming model that requires dynamic code.
Right.
But dynamic code is not available in a native AOT compiled scenario. There is no JIT compiler. The just-in-time compiler is gone, so everything must be compiled at compile time. There is no dynamic code that can be emitted. So minimal APIs would not work with native AOT.
Okay.
Unless we plug in a generator that generates interceptors, now intercepts those methods that wouldn't work in native AOT and provides a different implementation that actually does work with AOT. So the user doesn't need to change any code, just needs to ensure that in native AOT scenarios, this generator is available, generating interceptors. The application still should have the very same behavior, but it's now doing it a little bit differently and would work for native AOT as well.
Okay.
And those are the two main use cases of interceptors. We want to have them generated, because I don't want to go all over my code and now change this code to manual code, because this could be a lot. So generator is creating a lot of code. And then I don't want to update my code with this new call, with those new methods. Let also do the generator do that. So all I do is just plug in the generator, and now suddenly my application either becomes a little bit faster or supports native AOT scenarios. Awesome. Usually it's a combination of both.
That's awesome. All right. So why do we start with like updating
Let's actually start with documentation.
Okay.
So okay, yeah, that's a change.
That's a change.
So previously we had, actually there is a detailed, there's really detailed description of how generators work and how interceptors work. And there is new API has been added, because what we saw previously is that it is us. That's the wrong test, right? Let's go to the interceptor locator tests, the core tests. This one. We as a generator author, we need to add this attribute, and we also need then to basically construct this intercepts location string, because it's interceptors usually are source generated. So we need to create all of that. There was no real, we kind of had to know all of that. There was no Roslyn API that helps us with that. Now since Roslyn, that is, I believe, 17.11, to come a bit about the versioning scheme, is there maybe? Let's go to nougat.org. I hope there is for Microsoft.code analysis. Microsoft.code analysis. Those are all the Roslyn packages. So the compiler platform for Visual Basic and C# language. And I believe, is that here? No, is it this one? Yes, you see an overview of the versions. And okay, this is not 100% up to date, but for example,
wow,
Roslyn 4.0 was the version that shipped with Visual Studio 2022 and was the version that supported .NET 6. And in .NET 6, we had C# 10. You see the version before, that was C# 9 on .NET 5 and the previous version of Visual Studio. Per .NET release, there are 4 feature band releases. So we always have 4 Roslyn releases before we jump to the next .NET version. So we have 4 Roslyn releases in .NET 6. We have 4 Roslyn in .NET 7. We have 4 in .NET 8. What's missing there is 4.11.
Okay.
What did I say? I said 17.11. 17.11, actually, that would be the Visual Studio version.
Okay.
Basically this one here. I used the wrong version.
It's okay.
But we also see that this is always in line. So the minor version of Visual Studio is always referring to the minor version of the current supported Roslyn compiler.
Okay.
And well, 4.11 and 17.11. So the last feature band release of .NET 8 now had the new version of interceptors in place. I mean, interceptors originally were experimental, so stuff was very likely to change. And in 4.11, I'm always using it wrong. Now that .NET 9 is out, this one. Now that .NET 9 is out, the version of Roslyn is 4.12. And the version of Visual Studio is 14.12.
17.12.
And what was added in 4.11 is, so this attribute has changed. This attribute now is no longer string int. It's now an integer version. So there is some way that the Roslyn team can evolve this design of this attribute, so they don't need to create a new attribute, but just change this version that the compiler then needs to respect, and a string data. And the string data now contains this information, but there is some implementation detail of how they generate this string data. It's some encoded hashed string.
Oh gosh.
That if you know the rules, I guess you could extract this information, but we would not do that.
We wouldn't?
No, we wouldn't.
We don't know the rules?
We don't know the rules. We don't know we could learn the rules, but it's rather difficult. And then when this version changes to version 2, now maybe these rules have changed as well, and we would need to decode the string differently to come to the intercepted location, which would be a lot of work.
Sounds exhausting. Let's not do that. Let's just...
But to circumvent it, there is now actual APIs that support interceptors. So we now have a method, get interceptable location.
Yes.
Where we can get the interceptable location, which is now having the version and the string data.
Yep.
And there is an extension method. Do they mention this here as well? Yes, they do. No, they don't. But there is also an extension method where we can translate now this interceptable location to the string, this entire string that we need to generate here. So this entire thing that we built earlier ourselves, there is an extension method that creates that. So all we need to do is to find out via Roslyn the method that we want to intercept, get this as an interceptable location, and ask the interceptable location to generate the string. And this is now the change. So we don't need to do, to find out something by exact location and file path anymore. We just need to get a reference to this invocation of the method that we want to intercept, pass it into these new Roslyn methods, and then we can generate our interceptor, which is now a programming model that is way much more in line with Roslyn than doing this on a very character-based level.
Okay.
Eric is mentioning that the versioning rule
my
of
7-Eleven rule.
.NET.
I'm glad you remember it. Yeah.
Where's the versioning? Was that here? Yeah. So the 711 rule is that .NET 7
Yeah.
shipped C# 11. Therefore, .NET 8 will ship C# 12. .NET 9 now has shipped C# 13, and in a year, .NET 10 will ship C# 14.
Yeah, I guess it was really useful because 7-Eleven, like the shop, you remember it easily. But I guess like in a couple of years, when there are tons of versions out, because right now I'm always like thinking back to 7-Eleven and then, go up. But I guess in like 8 years, I'm going to have to come up with something more fun. But yeah,
So
for now, it's okay.
when we have .NET 50, what's now the C# version?
Oh, goodness.
But it's
Well,
always
we'll get to that.
Well, it's +4, but yeah.
Oh, okay.
Yeah, that's
Well, that
less
was easy.
exciting. But I like 7-Eleven more than +4.
Yeah.
And yeah, so what we can do now is, as a source generator author, use these new APIs to generate this new intercept location attribute.
Yes.
But now also as a tool vendor, we also need to update our interceptor locator to find these new ones. And we also use that with Roslyn APIs. So we will stop doing stuff with very location-based and finding characters and paths and all of that. We just need to find the right method, invoke some Roslyn stuff on that, and then be cool with it. I hope.
You make it sound very simple and straightforward, but yes? Really?
Okay. Yeah, no, I do make it sound simple and straightforward, but it isn't.
Yeah, I was going to say, it's like, I doubt it's going to be that. Okay. But okay, where do we start?
I have never really done either of those two things.
Yes.
I played a little bit with the generation part, but not with the our locator part. So we need to find it out as we go. And I hope we don't hit too many exceptions. Excuse me. Where do we start? That's a good question. Yeah. I guess with a test. So we do have one test where we provide our own generator. Maybe let's use this as an entry point. Trying to find that. So I was there already at generator, right? Yes.
Woo.
Maybe I zoom out just a little bit if this is still good. So here we have our own generator. Maybe let's run this test to see if it is passing, because under the hood we kind of prepared for the other session. So we did upgrade to .NET 9. That's what we were hoping. Yeah. Just in time, we also updated to the latest Roslyn version. So we updated to the 4.12.0. That's not fully out yet. There is also the NuGet package is still in preview. The full package is just not out yet. Should be released in the next days. But I guess I don't think there is any breaking changes anymore going on. But now, since we have upgraded, we have a test that is failing. The interceptors feature is not enabled in this namespace.
Okay.
Oh no, this is what we invalid operation exception. So we need to. Oh, we don't do that. I thought we do, because we then say with feature interceptors preview names. Ooh, is the preview now gone? Maybe it's no longer interceptors preview namespace. Is it now just interceptors namespace? Indicating that they are no longer experimental, but now actually there. Yes.
Yes. Awesome. Easy.
So interceptors are no longer in preview. Cool. What the 4.11 plus version, or this new int version string data variant, is no longer in preview.
Nice.
And we have a passing test. Now let's break it. So here's our interceptor generator. Okay. I haven't looked at this in quite a while now. We need to.
I know.
So what was this interceptor generator doing? Maybe let's back. We have here.
Yeah.
Well, we call here a method.
Yep.
And the method that we are calling here has the interceptable attribute. But this is just an attribute that we defined. Where did we define it? Not sure. Where did we define it?
Because these two things are also in different documents. So, right?
Invoker.
Invoker.
Yes.
Okay. Yeah.
Those are different documents.
Yeah.
Now, and this interceptable attribute, that's actually also generated by the source generator. So the source generator is creating this interceptable attribute that we are using here. And every method that we are tagging with interceptable, we want the source generator to actually intercept.
Yeah.
So invocations to this method should be intercepted. Now let's see if we recall correctly what we did a year ago, something.
It's only been a year, but that's the thing. Like, I didn't.
Gone.
Totally gone.
So first we, with the post initialization, we can unconditionally do something like emit this attribute, so that then on the user side we can attribute methods with it. Now I guess we need to find methods that have this attribute. So we provide a syntax provider. No, actually we don't. We find every invocation expression. So what we do is we find everything that is invoked, like a method invocation.
Yeah.
I guess then we need to check if it is, we now have here our invocation, and we check if we also get this attribute. We can get this by metadata info, and then we check if the invoked method has this attribute. So we find this method, then we find the invoked method, and we check, does this invoked method really has the interceptable attribute? And I believe this is, so this is what we're doing here. If we have this attribute defined, now we can, for this method, for this invocation here, we now want to create an interceptor. And we do that by expecting, by creating a new method that has, what is that, line 1 to line 3, character 1, 2, 3, 4, 5, 6, 7, 8, 9, as with the location callsite.cs. So we need to get all of that information. We need to get the file path. We need to get the line and the character, and now know what we're gonna intercept. So then in the generation phase where we actually produce our source code, here we now create our interceptor, and we say, okay, please intercept this location at this file path with this line and this character.
And this we can now, I guess, change, right?
And this is now what we're gonna change. Yes, we see we also source generate this intercepts location attribute, because this is what the source generator, what the interceptor actually needs. So we still gotta do that, but we now need to change to this new format. So string file path character is no longer the thing. We need to change to the new variant. So let's jump back to the documentation, because it's now this one. Int version string data. So let's change it to int version string data. This is a new attribute. So this is now wrong, but we don't need to create this entire thing. We can actually ask Roslyn to do so. But I guess we need to get that string first. Maybe we can have on our source actually just put this. Oops. This is called intercepts location. So maybe we instead want to have a property that has intercepts location attribute.
Okay.
So on our model, we now need to supply, I guess, which parts do we need? We no longer need these three. We just need a string for the intercepts location attribute. Ooh. Now we come into the sphere of I'm mispronouncing. Is it variant or variant?
Variant.
Variant.
Pretty sure. I'm very confident. I'm not a native English speaker, so if you are, please correct me. But I said it's variant. What do you think? What did you said? What did you say?
What did I say?
I don't know.
I guess I said it wrong, but I I think I said variant, but it's no, I said variant. Variant. Because it varies, it's a variable.
Yeah.
Those are the mistake they always make. Yeah. It's a variable, it varies, so it's a variant. Yeah. Okay, it's not only C# I'm learning, also English. Still.
Yeah, that's another nice thing about this show, I guess. You learn some German, learn some English. It's always something. Some C# as well. All right.
We updated our model, and we're using it, but now we need to fill it properly. So here we now need this string somehow. So how can we get that?
Yeah.
Now it goes into the fun. Okay, documentation time.
Yeah.
Where do we get this interceptable location from? We need a semantic model.
Yeah.
And we need an invocation expression.
Syntax.
What does this do? If node cannot be intercepted, it returns null. Otherwise, returns an interceptable location instance, which can be used to intercept the call donated by node. Okay, so we need to, I think we are quite there. Because what we need is, if I read that right, we basically need this method.
Oh.
We need this method invocation.
Yeah. Okay.
If I get that right. And well, it's actually just an invocation. It doesn't say method invocation.
Okay.
It just says invocation. So if it was like a property invocation, it wouldn't work because properties aren't interceptable. Therefore, I think it would return null. But if it's a interceptable, so-called ordinary method, so also not a constructor, not a local function. There is quite some non-ordinary methods, but a good old regular instance method or static method that is interceptable, and I'm hoping this then returns not null, and then we can move forward with getting the string.
Okay, so the node is the node where the invocation of the method is, right?
No.
What's the model? No.
No, so this is not a location. This is the actual invocation.
No. Okay,
because you said where this invocation is. It's not really where this is. It's rather this it also, it also includes the information where it is, but it's less about this location as it was with the previous model. It's more about this invocation that is happening exactly here.
Okay.
So yes, it also includes the location.
No, but I know what you mean. I know what you mean, because you're right. I'm totally still thinking about kind of like translating what we previously had to what we now have. But what's the other parameter, like the model thing?
The semantic model. Well, we see this is an extension method. So we need the semantic model. We need the semantic model to ask the get interceptable location question for this invocation.
Okay.
So do we have in our generator here, do we have the semantic model available? We have here a generator syntax context, and this generator syntax context has a semantic model indeed available.
Easy. Okay, perfect.
So we should be able to say semantic model dot.
Yep.
Now we call get interceptable location.
Yep.
It doesn't exist. We see this is an extension method, so it doesn't exist on this type, but it's rather an extension method in code analysis C# extensions. So we need to include that. Import missing references. I guess up there we now have C# extensions. This quite did not work.
Okay.
It still doesn't work. Maybe we do it manually.
Yeah.
So we need using .C# extensions. Ooh, does not exist. Wait a minute, that's a static method. That's not a namespace. Never mind. Oh, we already have. This should work. Why does this not work? Yes. Interesting.
What does this say? Maybe it's also just the cannot resolve symbol. Okay.
maybe has it been renamed? Interceptable.
Get
interceptable location. Oh. Get interceptable location, but it says the same. Ooh, what Weidana does, it transforms this. Oh, is this no longer an? No, this is this method. This is the method that we took a look at, and this is indeed in C# extensions, and it's a public extension method. So why is this not working as an extension method? Oh, maybe because we didn't provide that.
Yeah.
Just for if we have a syntax node, also a cancellation. We do have a cancellation token, don't we? Yes, we do. So we can forward that as well. But I'm wondering why because now we have the static invocation, I'm wondering why we can't invoke it as a...
Weird.
I do not understand that. Is this a problem that Rider has, or is this a problem that... Okay, something I don't understand, but yeah, we should still be able to invoke it as a
exceptional
regular static method.
As we promised at the beginning of the episode.
Very exceptional. The problem is that this API is still because we don't have the full 12.0.4.12 release yet. We are still on a pre-release.
Yep.
And for this pre-release, this new APIs, since at this time this was released, it wasn't sure yet if this is the final shape. So they are marked with something that is, I think, a C# 12 feature. We got this last year, experimental.
Yeah.
And when you try to invoke, maybe this is why the extension method doesn't work, because it's experimental. Could be. And since it's experimental, we get a compiler error. And this compiler error says that this experimental method is for evaluation purposes only and is subject to change or removal. What we need to do is to suppress this warning. We could say, for example, either via a pragma. So we can say, pragma, please disable the error with this ID. We see RS experimental 002. This is the ID that we also see here. There it is, RS experimental 002, which I guess stands for Roslyn experimental. So there's also a Roslyn experimental 001. I don't know what that is, but there is something. And either like that, or we can also suppress it via an attribute on the method, I think. But there is no auto-completion that I see here, so let's maybe stick with that.
Okay.
So we're now saying, okay, we're opting into experimental behavior. We are well aware that this may change, and then our code may not compile anymore. And now, since we suppress it, now we may invoke it as an extension method. Still not. Okay, then let's keep with the static invocation. And this now returns an interceptable location. Okay. This interceptable location is nullable. So if this method is not interceptable, this may be null. So, well, in the case it is null, do we have a fallback? What do we do? If, so in the case, well, I guess we can just return, but what do we return? We just return default. So in the case this interceptable location is null, so in the case that it's not interceptable, we just return default. Okay. If it is, now I guess we also need to move that in here, because the interceptable location type is the entire type is marked experimental. So the entire type, including all of its members. So we need to have this in here as well. Now on the location, there is not this one. This also, because we didn't see this, we didn't see this on the method itself, but I mentioned there is an extension method that provides us with that thing that we need, and this is here. Now this is also an extension method on the interceptable location that now provides us, and here we see that provides us with that string.
Perfect. Yeah.
Intercept location attribute with the version and the data. So we don't need to take care about that. And we add this into our model. And I think our interceptor is not quite done.
Oh, easy.
So let's run our test, and we should fail. I'm not sure where we should fail. What is our expectation? Well, our expectation is that we detect an interception at a specific location. And I believe our interceptor locator now will not work anymore.
Oh, yep. Yes.
We fail because we expected, but actual is totally empty.
Oh, nothing. We got nothing.
We got nothing.
Okay. Yeah.
And I guess now it's time for our... I'm wondering, should we switch to another project to confirm that this interception is really, really, really working? Because we do have this interceptor that we mentioned earlier, this enum interceptor. I'm wondering if I have that project open, and I guess we should be able to do this because now we know how it works. If we are able to do this quite quickly, maybe let's go to the project that is producing this generator to be able to more or less confirm that we applied the correct programming model here. Now, of course, this is definitely not prepared at all. Let me quickly see where we have dependencies to Roslyn so that we can change to the latest 12. What was that? -3 final?
Something. Maybe final and then 2.
Oh, actually 4.11 has the change included already. So
easy.
It should be fine.
Perfect.
And
it's so funny that I'm like surprised that I don't remember stuff that we did last year when I don't remember stuff that I just saw like 2 minutes ago. Oh yeah.
So let's jump to our generator. Here's the enum interceptor generator.
Yes.
And the enum interceptor generator, maybe let's try not to focus on the code too much, but we see, yeah, here is this thing is emitted. We have some location here. Maybe I'll just quickly, let's replace this with the string intercept. I call it the string for now, just to see it working.
Yes, the string.
The string, and it fails here because the string is not available. So all we want to do is now basically write
the string.
Every location dot the string. And now we need to produce the string. Yeah, here we do the same thing. So eventually we need here the string. Do we have do we have the invocation? Do we have, so we find again invocations, simple info, get simple info, the invocation. This should be the invocation. So it may be as simple as location. No, we also called it location. I call it L equals. You need a semantic model.
Or
we can ask
the location.
The location. Come on, the location. We asked just as we did before, the semantic model to get us an interceptable location. Passing the semantic model, passing in the invocation, passing in the cancellation token, also applying this pragma to suppress the warning because it's very experimental in this version.
Yep.
Let's also say if the location is now, what do we return as a default? Are we in a loop or something? We are not in any loop, so I guess we just return default. Yeah, we just return null. And then is this the correct thing?
Do we need that?
And I'm wondering why.
Because we already have the location, right?
Now we asked location to get the syntax.
Easy. Oh, what?
Should be kind of it, but we do have a compiler error, unexpected token. Oh, I didn't put a semicolon at the end here.
Okay, fair enough.
And now it compiles. Now let's see, enum interceptor. If we run this now, there is no. Because since we also have a test project for here, this is basically what I wanted to test, to have an, where's the is defined? Yes, because we actually do in, or maybe in the examples, we should be able to show it in examples, to see the interception of these two methods, if this really, really is working.
All right.
So what I'm hoping is, well, first of all, what I'm hoping is this, that Rider understands this new IDE errors. Maybe Rider is not aware of this new interceptors just yet. I mean, they're still experimental, so it wouldn't be all too bad. But now I get this assembly things again. Can I run this? No, I can't. Okay, not sure what the problem is. What I was hoping is to see in the source generators now this new version. Well, there it is actually.
Oh.
But yes, I forgot. Mira, of course, the new enum interceptor generator also needs to, because we still emit the old attribute. Where is it? Where is it?
Oh my goodness.
Because we also need to emit the attribute. Do we do this as a? I think it's, where is it? Here, that's the body of the method. Where do we write the actual attribute? Maybe we have the source also laying around the attributes. No. How is it called? The intercepts location. Let's find it. There it is.
Okay. Oops.
Didn't update the attribute. But if we now update the attribute, yeah, okay, build kind of looks better. No, I just made a mistake. It was not Rider's problem. And now we should see in the source-generated output that this new attribute is emitted and it's used here and no errors. Now I'm wondering if Rider understands and will actually navigate to this new intercepted method. So basically confirming that the program model that we're using, these interceptors, are really, really working. So we are not in the application that I expected. I want to debug this one. Oh, examples 1. Oh, it actually was what I wanted to debug. Sorry. I haven't been in this project in quite a while.
How dare you?
Cool. Now this one should be intercepted, and if we hit F11,
Yep.
it does go into the interceptor. We see that here. This is now generated code, and this is now a very special case interceptor that only works for system comparison. Well, and all it does is just to switch over the values and returning them as a name of.
Yep.
And likewise, the is defined now should also be intercepted. So we don't go, if I have 12 this, we don't go into the original BCL defined enum.cs, but we go into our source interpolation handler, some more stuff. There we go.
Nice.
So our source generated interceptor that's now checking the is defined, and all it does is does this value any of these 6 values, and if it isn't, return false, otherwise return true. Cool.
Awesome. So this is kind of like the manual test. Now we're fixing the automated test, yeah? Or no?
Yes. So yes, indeed. We now confirmed that the program model that we're using, getting this invocation and emitting this attribute, that's actually working. That's really, really good. So the test that is failing that we have is meaningful, because we never trust a failing test.
That's not how this goes. It says you never test a passing test.
Ah, right.
I mean, you shouldn't test
myself.
Passing test.
Well, if it's later on passing, now we can't trust it. Well, I hope. And now I lost my trail of thought. What's the next? So now we need to update our locator to find.
Yes.
Now we go into the fun zone. Oops.
Oh, wait, really? Oh, because it's fun because you haven't looked at it.
Mm-mm.
Okay, cool.
Not at all.
Awesome. That's fine.
I guess this is why I have the documentation open, because no idea.
Okay.
There is another method that I can't see here. Maybe that's a different API proposal. I guess we could find this in the documentation eventually. Is this here? To determine calls being intercepted. Yes, because this is the API that is needed to create an interceptor. But what about the other way? How do we find, because now we can't really, we can't read this data string. That's something, we can't really decode that. So the team also provided APIs to basically do the opposite, to find out whether something is intercepted. And there is now also, via the semantic model and via an invocation, we can ask for the interceptor method, which I believe returns if the call represented by this node is referenced in an intercepts location attribute. In other words, is this method intercepted?
Yeah.
Return the original definition symbol, which is decorated with that attribute. What's does this mean?
Symbol?
Returns a symbol. There is nodes and symbols. A node is syntactic.
Yep.
And the symbol is semantic. So we get semantic information, not only how this looks like in C#, but actually what it means, what method it is, what real types it has.
Okay.
And also where it is, I think, in which type is it contained, and so on.
Okay.
And returns the original definition symbol, which is decorated with that attribute. So I guess in other words, we get the interceptor. But if this call is not referenced by an interceptor, so if this call is not intercepted, then it returns null.
Okay.
So if I get that right, we need to check every method invocation, or we could even ask every invocation and ask, hey, are you intercepted?
Yes.
If it says, yes, I am, we collect them. If it says, no, I'm not, we discard them. And then we have all of the intercepted calls. And then I don't know how we go further, but we'll figure it out.
Okay, we'll figure it out.
So I guess, what we had earlier, we already had a walker. We had an interceptor walker.
Yeah.
But, I guess, should we rewrite that one. Maybe let's create a new one. How is this method called? That's the get interceptor method. Interceptor walker is a good name. Let's call it interceptor walker 2.
Yeah. Okay.
For now, and lack of a better name.
Okay.
We seal that because we don't intend to derive it, and we have our C# syntax
Walker.
No, it's not a super. It's not a syntax walker. Is it? Yes, no, it is a syntax walker. C# syntax walker. There we go. Now we can override a lot of things, and we need to visit invocations. Let's see what we have in the land of invocation. Well, invocation expression. That's the invocation expression syntax. I believe this is exactly what we need. Yes, maybe I'll just copy this here, so that we have it for, then we don't need to tab in and out all the time. We need an invocation expression syntax, so we indeed go through all the invocation syntaxes and ask them, are you interceptable? We need a semantic model, so let's pass in the current semantic model. Should we do a primary constructor? Makes it a little bit shorter. We pass in the semantic model, and we can now ask the semantic model to get interceptor method. It's also cancelable, right? So we may also want to pass in a cancellation token. And we ask, please give me for this node the interceptor. This may be null. If it is, so yeah, we again get, because it's experimental API, so we need to suppress these warnings. We opt in to this experiment. Well, currently it's still, I can imagine, well, I hope that with the full proper 4.12.0 release, this, well, I can imagine that it's gone. Well, maybe this attribute will be still there. Maybe they want to change something about this API, but the interceptor itself, how the interceptor is created, I think this is now stable.
Okay.
But this API in Roslyn, this may still change. And cool. And then we need to add these to a collection. So we also create ourselves a, let's do a list of these method symbols. Interceptors. Let's initialize it empty. And we add to this list only if it's not null. Well, if we add it like so, we would get a nullable warning, but we only want to add it if it's not null. And with that, we may actually have all the interceptors. Why do we have a warning here? Collection of interceptors is only updated but never used. Oh yes, we're not using that just yet. And I think this may suffice already to get what is significantly less code than what we had earlier.
Yeah.
And with that, we should get all of the interceptors.
Okay.
So, okay, what does our interceptors locator do? It goes, it throws if the project is not C#, because intercept is only supported for C# currently, not for Visual Basic.
Yes.
We get a compilation, we check, and we find interceptors. Yes. So I guess maybe let's supply the same model that we here have. And we go, actually, we don't go through, we don't need to do this method things anymore, do we? Is it as simple as calling? Well, we need a compilation. So we now create our new walker. We need a semantic model. We can get that from the... Oh, we get that per document. Well, we have some helpers to extract the semantic model. Let's see what versions, what overloads we have. We have one per document. Oh, we have only one for the document. Do we need a document? Can we not get this from the compilation? Oh, yes, we can. Oh, but that requires a syntax tree. Okay, then I guess we need to do it. We still need to do this per document. So we do need, maybe let's bring the code back. So we do need all the documents. We get the syntax tree. We get the semantic model. Okay, maybe let's just here do that.
Okay, but if we can get the syntax tree, we can just use the method that you had before, right? No, the helper method.
Excuse me?
Didn't like before, like you had like a little extension method where you could just get it via syntax tree?
Mm-hmm.
Isn't that?
Yes, but we actually I don't think we need the syntax tree anymore. I think we can get rid of that.
Oh, we don't want to use syntax tree. Okay, cool.
I don't think we.
Okay.
Unless because we now just pass to the. Ooh, you know what? Maybe we still need it. Just because I forgot how the walker works. So we now create the new walker, and when we what can we visit? We visit and maybe let's keep that code as is. We visit the compilation unit. So yeah, we're actually now extracting the compilation unit. And cool. So what we now do is we now get interceptors from this walker.
Yes.
But this is now iMethod symbol. This used to be interceptor info.
Yes.
Interceptor info had document line character method. I'm not sure if we lose this information. Maybe let's try to be. Maybe let's not return a. Where are we? In the walker. Maybe let's not return a method symbol, but actually return the interceptor info. And maybe we can, from the method symbol, but also from the invocation expression, extract all of that information. So the interceptor info takes, we actually have a create method on there. Okay, well, we're not going to do that. We are calling, okay, we need the document, the line, the character, and the method, or the name of the method. Let's see if we can extract that out of there. Do we know from the node, do we know in which document that is in? We don't know we don't know in which file a node is in. Well, maybe we don't need this information, I hope. Let's say we don't know yet. The line. There must be a location. Get location. Get line span. I'll keep this all -1 for now. Maybe let's figure that out later. But we do know the method name because the interceptor should have a name. Cool. So what's then the next step in our interceptor locator after we got all of the interceptors? We now find the intercepted calls.
Yes.
But do we need to do that because we actually know the intercepted call already, don't we? I think we can do this all in one step now. What we previously had to do in 2 steps. Because here we know the interceptor. And here we have the intercepted. And what is the information that we actually then return in our locator? We then return an interceptor list. And this interceptor lists consists of interceptor infos.
Yeah.
And okay, I guess we should then be able to change, because we have that information. I don't think we need to do this anymore, where we build up a lot of stuff. I'm not sure now. How do we best do this?
We could just return like whatever we have and then see in the test what it looks like.
That's also fair. Well, currently we asked the walker, the interceptors. Yeah, because we do. Yeah, I don't think we need to go. You're right. Let's see where we are. It's actually always a good idea.
Okay.
Question is, does it still make sense that we? Well, I guess we should. I guess we still are able to extract all of this information.
But maybe we question is, does it make sense?
Shuffle some code around. Because in the locator here, I think here we do all of the code to find the exact locations and such.
But so can you go back to the test?
Yeah.
And what we saw, because I didn't quite. So the actual is interceptor at, then we have this little thing that we did, and then intercepts 0 locations. Why? Didn't we intercept something? No.
Yes, but we didn't add it to our internal list yet.
Oh. Okay.
So let's do that. Maybe we just in the walk. Maybe we can build it up all in the walker. Maybe in the walker, maybe that suffices, and we create here our interceptor list. So the walker now yields interceptor list. Maybe let's call this result. And the interceptor list requires a project name. Let's pass it in. We have project and project.name.
Easy. Oh.
And now we can say project name. Cool. And then we should be able to add an interceptor info. But I think that's not the tricky part, because an interceptor info, what our data structure, we have an interceptor info, and that already contains, that's a single interceptor that intercepts multiple locations. So we kind of need to group them now, that we don't do right now. So maybe let's have the walker, let's leave the walker as is. It just returns, maybe let's leave the walker as is, and it just returns this interceptor methods. Or maybe it returns a tuple of both. We have the interceptor, we have the interceptor, and also the intercepted. Maybe let's record both. And then we just add the interceptor and this intercepted node. And then we try to figure it out from here what we do. And
okay.
Yeah. Interceptor, what's the return type? Interceptor list. And let's try to find that all in here, where we now create So this is now this will now be this tuple. Let's copy that again. And we will have all of the intercepts. So first, when we go through all the documents and we have the walker, we want to add to this interceptors list. So we then add, yes, cool. And now afterwards, we now need to create this interceptors list somehow. We do have the project name.
Yep.
And now we want to add an interceptor info. The interceptor info now is the interceptor itself. But we now have a flat list. We have a flat list of interceptors and the calls that they intercept. So we could group the same interceptor, we group the interceptor by, so we group here now by interceptor.
Okay.
And have then all of the intercepted calls that each interceptor intercepts. So it's time for some link.
Would
like to try some
perfect. Link? Okay.
This is not going to be easy. I need to think as well quite a bit.
It's not going to be easy to let me do it. Oh, no.
Yes.
Okay, no.
So we want to group by interceptor. The signature of group by is we get in, well, we basically have this tuple available. So maybe call it, I don't know, just some, maybe I for interceptor, just a simple name.
What? I?
Because, well, like we need a lambda, yeah. So let's write a lambda that takes an I.
Oh. Oh my goodness, I'm scared.
That was good.
Okay. Oh my goodness. All right.
And let's see what we have on I.
Interceptor.
And this may suffice already. I'm not sure what this is. Let's call this group for now.
Groupo.
A bit of a crazy type. So this now is an enumerable of groupings that are grouped by the method symbol, but also this. The problem is method symbols are not comparable.
What?
I think we need to
why?
No, sorry, they are not equatable. When we check I method symbol, that implements I symbol, and it actually is. I thought they aren't, but I learned it somewhere. We need to. There is a special equality comparer that we need to use when you do something with symbols, and I think it's called a symbol equality comparer. We need to use that one, and maybe use just the default. And we should be able to pass that to the group by method. This should have an overload that takes an equality comparer. So we don't use the default equality comparer, but the equality comparer that we supply. And this takes a long time. Browsing the source code, key selector. Yes. So we have this overload and we used another one. We have the key selector, but just pass a equality comparer. So it should suffice if we just do that, but it isn't, because cannot convert. What if we make the what if we make this var again and then do this is now a different type? Because not nullable. Okay. I symbol. This is not an I symbol. It's no longer a method symbol. Well, egal. And now, if we for each this group, I don't know yet.
We're great at naming today.
This is now a grouping of, and a grouping has a key and has many elements. So this would be an interceptor.
The group.
I use var here. This would be a group. The group.
Oh.
Let's call this grouping. And we can now, for each group, to get, I think that's the intercepted pair then. And this is now this pair where we have the interceptor and the intercepted, but now as a flat list again. I don't think this is what we want. Because now we kind of degroup it again. I think here is where we want to operate on. Because this method takes an interceptor info and an interceptor info really requires these things.
Yeah, okay.
There's actually, we do have a create method. Maybe this create method actually helps us because, well, we need a method symbol. Okay. We need a method declaration syntax. Do we have that? No, we have a method invocation. We don't have the declaration. But what do we use it for? We use it to get the syntax tree and the identifier to get the location and all of that. Well, I guess in best case, we could just supply this create method. Let's see if we manage to do that. We need a compilation. We have a compilation. We need some symbol. We need we do have the method symbol. This will be, I don't know yet, I do now, the group dot key. We kind of lose the information that this was a method. Also, no, we actually do have the key. Wait a minute, why is this now a nice symbol? But it actually is this method symbol, I hope. So we should be able to cast this into a method symbol. But how do we get the method declaration syntax?
Well, if we use it for this location, right? But don't we already have the location? No.
Do we have the location? Well, we need to extract that information. So can we get the location differently?
Yeah. Isn't that like part of the thing? Because then we can just have like an overload of the create method, right? Where we just pass in the location. No.
Oh.
Or are there two different?
Good thinking, because locations? We use this also to get the file path. But do we have the file? Well, we know in which document we are, aren't we? Or don't we?
Oh, we do.
No, wait a minute.
And it's like full name or something is file path. No.
Well, we don't have that here anymore because we are outside of the loop now. But maybe we can enhance. Maybe let's just pass it in. Let's say we have now our.
I think it might be easier to get the declaration, right? Or
yeah, I guess so. Yes, indeed. Because, well, the thing is, very great idea. So the problem is we don't have the what we need the node for, but just with the node, we need it for the file path. So maybe string file path. Let's pass it in. Problem kind of solved. And we also needed to get the location. But perhaps we can get this location differently. Basically doing it like, oh yeah, you mentioned let's do another overload. Good call, so that we don't break anything else. We pass in the string file path and we pass in a location.
Get rid of these two.
Yes. Okay, cool. I need to supply this new create method. Just copying the signature here. And okay, so now in the walker, maybe we enhance this. Maybe let's out of this, let's create our own type. I'm just getting quite big, this tuple. Let's create an internal sealed record class, struct, doesn't matter, record class. That we call, I don't know yet, tuple.
The tuple.
The tuple. That contains offset information. It has the interceptor, it has that, it also should get the string file path and also the location. I think that's the location of the interceptor. And now we return the tuple. Or is it tuple?
Ooh, no clue.
And how do we get the file path? Well, I guess the file path we can pass in here. But how do we get the location? We need the location of the interceptor, I believe. We have here the interceptor, but that's a method symbol. I don't think that has a location any. Well, it has multiple locations.
Why? Oh.
Yeah, because it's a symbol, we don't get the syntax as a location. A symbol doesn't. A syntax has a location in source. A symbol does not. So maybe we can ask, yeah, assistant. Yeah, assistant. No. Coding has forsaken us today, indeed.
What? Yeah, what is going on like today? It's insane.
Oh, it's forcing me to ask a different one. Well, well, that's classically Google. Or Edge. Is that a verb? No, it's not. I forgot what we want to do. I don't think we can.
Roslyn. So, can you...
Excuse me?
Can you remind me again? I know we've said it twice today already. I don't need to hear it the third time. When we get this interceptor, we pass in a node, right? What is that node again?
So this node, that's the invocation of the original method that we then realize here is actually intercepted by this method.
Okay, so it doesn't have any locations of anything. It just knows that it has this attribute.
Yeah.
Interceptor. Yeah, okay.
So maybe let's ditch this information for now.
Okay.
Because I quite don't know. Maybe there's something that we can't get via these APIs. We could get a symbol. Well, maybe we could get somehow. Well, the symbol has. Well, the thing is that this symbol has, of course, locations. I think this is because of partials. We can have partial methods or partial types. So this is why we have locations. But maybe in our case, we kind of can't assume that there is only one. And be good with it. Maybe let's try that. Yeah, because, well, from syntactically, if you find a node, that's one. Maybe let's. Well, do you know what I mean?
Nope.
So when we are from a syntactical point, so when we in syntax node land, we could have a class. We could make this class partial. Well, let's do in methods. We could have a partial method here, and maybe make this a partial class, and then have another partial class C, which now has the other part of actually supplies the implementation of this method M. So you have here our partial declaration, and here's our partial implementation. So syntactically, those are two method declaration nodes. So we have two nodes. But symbolically, when we now ask the semantic model, hey, please give me the symbol for that, there's only one symbol, the actual method. But now from a symbolic view, the actual method symbol now actually has two locations.
Okay.
From a syntax node perspective, there is two different locations that result in one symbol because they are partial.
Yeah.
So we now cannot be 100% sure. Maybe there is a way to find out. Well, again, is partial. If this is okay. Well, what? Okay, what is returns true if this is a partial method definition without the body. If there is an implementation body, it can be retrieved with partial implementation part. Cool. So what we should be able to do is, would you like to write a little bit of link here that selects only the locations that, maybe let's put it into a line. We have location, a single location that is not the partial definition.
Cool. Where do I write it? Here?
How can we, with link, how can we filter? With which method do we use to filter elements to get a potentially smaller
I know this. I do know this. However, it's late and my brain stopped working a while ago.
In link, can you remember what SQL is?
Select.
Select, not quite. Select is a transformation. The filter is where.
Oh no! Yes, I know this. I do know this. I promise. Okay.
I think actually in JavaScript it's called filter. So yeah, it's called differently everywhere.
Okay. So
let's do before the single between here. Let's do the where and filter locations.
Locations where. Ooh, what happened? Sorry.
Oh, wait a minute. Sorry, my bad. Actually, does the location? No, I was thinking the location doesn't have this information. Oh, I was thinking wrong. Actually, wait a minute. No, we don't know. Can we? No, I think this actually should suffice. We're quite we're quite depending on what this method returns. So I don't think there is anything we can do. No, because in here, well, we could. No, it doesn't really work. I thought wrong. I hope this works. We get an error here if we don't have a single one. Cool. So now going back to our interceptor, what do we need to pass into our walker? We also need the file path. So we have the file path from project. File path. And we have our interceptors here, but those we no longer have this tuple thing, but we actually have, what was it called? The tuple.
You could also have the tuple thing, but
the tuple thing. Maybe let's stick with var here. Then we go through the group, and now in the group, we should now have the file path available. No, we don't, because is that on the key of the group? Key.filepath. Also not. The group is a grouping of system of where doesn't it show the actual types? I was hoping, does it not? Doesn't show the actual types. Okay, control dot. The tuple. Oh, that's a value. I think I made. I can't wrap my head around. Is this a different location? Because in the tuple we have the location of the interceptor.
But isn't that what we want?
Confusing myself. Yeah, but here we're now creating an interceptor, so we need the location of the interceptor.
No.
Here we need the location of the interceptor. Oh, this is confusing. And we have to
yeah. And the tuple has what?
We have per method symbol.
Yeah.
We have the tuple. The tuple now has the location of the interceptor.
Yeah, but that's what we need.
Or do they all have the same?
Isn't that?
If it's the same, if it's the same interceptor, yes, you're right. That's all we need. So what we should be able to, if we enter here, yes, we should be able to ask the group, get the first one because it doesn't matter, and get the location here. I think.
Yeah. I think it's now maybe. What's going on?
And then we need the locate. So that was and with the file path. I guess we also have that here.
Easy. Okay.
And what's the null that we pass in here? Yes, the method declaration, but we don't need that anymore, right? Because this create now takes. Oh, it also takes a compilation. Oh, so let's see what we actually consume here. We don't. Oh, we don't use anything of that anymore. We can just get rid of that.
Nice.
So we only need the method symbol, but we have that here.
Okay.
So we may now have our interceptor, but we need to fill that interceptor with interceptions.
Yes.
And I think now this is where we can for each the group.
Oh my goodness. Yes.
Interception.
Yes.
Where we have now this tuple. And this tuple now, basically here we have the intercept, or that's the intercept head. Yes?
Oh, yes.
And I hope now from this we can extract, I totally forgot what we need for we need an interception info. What do we need for that? We have the intercepts location attribute arguments, file path, line number, characters. We can't extract it. Can we?
Cannot?
I don't think so.
Yeah, but also, do we need it? Because isn't this the new...
This is new. Yeah, we kind of don't have this information, I think. We file path, line number, character, and the method, which is the intercept head method.
Intercepted
That's the intercept.
Well,
so we need also the location of the intercept head.
Oh my goodness. Yes.
Perhaps we have that because in the syntax walker, this is the intercepted method. So that node yields the information for the intercepted method. So perhaps we should now be able to ask, I call this the interception, or
nice.
The intercepted.
Nice. I like her naming.
Get the intercepted, and out of there, I hope we get all of this information that we need.
Okay.
So again, we have a create method. Do we have a create? No, we don't. We just have a new. Oops. Just have a new here that takes these. Let's see if we can get all of that information. I'm not sure about the file path. Maybe we need to extract it as well. And I'll get to the chat just in a minute to close that thought.
Yeah, because otherwise we're lost forever.
We have the intercepted. Do we get a location out of there? Yes, we do. And the question is, can we get out of this info? Okay. I think we actually do this kind of here, where we use this information to, from the location, we get a line and a character. I'll just grab this code here. Yeah, we may now have some duplications, but maybe that's okay for now. We get the line and the character.
Easy.
And where do we get the method from? Well, we should have that in the intercepted. Name. No, this is now intercepted. There we go.
Okay.
Name. Language. Name.
What? No.
How do we do this in this method? To display string.
Nope.
To string. Maybe to string suffices. And now we add these interceptions and should now have an interceptor. Maybe. And then we return that result, I suppose. We have a couple of compiler errors. Unexpected token. Add a semicolon here. And add a statement expected. Let's get rid of that. And let's run the test. Okay. In the meantime, let's go to the chat. Sorry for not responding quite. Scott is asking, what kind of stream is this? Would you like to try to answer it?
Yeah, of course.
Do we still know what we're doing? I'm not sure.
No, not really. No, this is like a quite regular coding stream. We stream every 2 weeks, and we just meet and we work on our .NET tool, and we have a couple of different features. Today's a little bit of an improvised episode, to be honest, because last year with C# 12, we had these experimental interceptors, and we wanted to make them kind of visible. And so we had a couple of interceptor locator, and yeah, a couple of things implemented into our tool. And so this year with C# 13, we just tried to update it to the latest standard and to all the things that have changed, because it does not work with the new version, the way that we built it. So this is what we're trying to do. But it's quite a deep subject, and I guess interceptors in general are a little bit new and a little bit difficult to wrap, especially my head around. And then there's also the said at the beginning of the stream that I'm definitely going to get confused with who's the interceptor, who's the intercepted, what are the locations, what are the attributes, and especially with the stuff that's changed. But yeah, so kind of right now we're really deep in what what are we? So we're trying to display the locations of the C? I don't know. Wait, is it
both of the
interceptors and the interceptees, I guess, right?
The interceptors and the intercepted.
Ted. All right.
Yes. And I guess, oops, there we go. So do you know what I was doing?
I can usually kind of follow, but your stuff is very quick, and as I said, it's we're quite in the thick of it, I guess.
It is a bit complicated, yes, and I totally made. I don't get it myself fully. But we are.
Yes, that's true.
We're close.
We totally get it. It's just
we're quite close. Because what we expect is that, we understand.
Yeah.
What the interceptor is, because we find the interceptor or the name of the interceptor. We also know almost where this interceptor is. Well, almost, because we do have, we don't know the file path of this interceptor, but we do get the location of the interceptor. So that's quite good.
Okay.
But then we lack some information for the interceptees. That is actually correct. You have the interceptor and the interceptee. Yes. For the intercept is the best is intercepted. Yeah. So we then have the location for the interceptee, which are not quite correct.
Quite right. Yeah. Well, 50%.
But we are
Less than 50%.
not that far away.
File path, I guess we have to give up on, right?
Well, we have file path here. Let's see. Well, we just write file path here. Can we understand where the interceptee is located? So can we get where the interceptee is located? Well, I guess we should be able to, isn't it? Because in the tuple, we have the file path. But that's the file path.
I thought, yeah. Oh.
So here, there should be the file path, should it not? No, but what's this file path then?
No, isn't that the interceptor?
Is this the file path?
Well, let's try it out. Let's see what it is.
We have tests, right?
Yeah.
And it's quite empty.
So I guess no.
So maybe we fill it wrongly in our walker when we try to get. Wait a minute, but we just forward this file path. This should be quite set, isn't it? Because when we do get, but this is the file path of the project.
Oh.
This is not the file path of the intercept. Actually, this would be this. Is this wrong? Document.file path. We're just passing here the wrong string here because we're not on the project. No, we're on the.
Well, okay.
Why is it still empty? Okay. But my head stops working. Maybe let's try one more go and see how far one think through, if this is any English, and see how far we get.
Let's try one thing through. All right. Oh yeah. Wait. Okay.
So we have.
Yes.
Okay. We do get the interceptor, but not quite the location of the interceptor. Do we know the location of the interceptor? Well, when we have the walker, we get here the interceptor method. So we're basically hoping that this one yields the information of the interceptor. Let's see if it does. Maybe this location, or maybe we do something wrong. So we do get the location here. This should be the location of the interceptor. What do we then? Oops. We then. Just passing this location to. Okay. Our naming now bites us a little bit. So
what do you mean? It's perfect.
In this the tuple, the location. Well, maybe let's give that a name. This is the interceptor location.
Yes.
Now going to the. Oops, I should have not closed the interceptor locator. We now create an interceptor info.
Yeah.
With the location of the interceptor location. It looks kind of good. What's going What's going wrong here? Thorsten Twinning is out. Thanks for joining. See you next time.
Thank you so much for joining. Have a good night.
Stuart, although
oh no,
still no internet. Okay, well we made the right choice of pivoting just in time.
Yes,
but we'll definitely catch up on what's new in C# 13 and .NET 9 next session. And Scott, the only interceptor that they know is Castle Async Interceptor. I don't know what that is. If it's Castle core, I think, is this maybe something with IL weaving? Async interceptor. Actually, yeah, there's many interceptors. So I guess this is an interceptor. Entity Framework also has interceptors, or has the concept of an interceptor. But yeah, we're talking about the Roslyn Interceptors, which are, again, a different way. Is an extension to casing dynamic process, simplify development of interceptors for asynchronous methods. So I guess this then does some IL weaving so we can intercept asynchronous. Is this to make? No, I'm not sure what it is.
I guess it's also a little late in the day, maybe.
But it intercepts methods, async methods, so we can maybe create our own code to. Does it say? The whys and wherefores implement intercepts link for discussion. Okay, it's part of aspect-oriented programming. An interceptor catches exception and logs them. So that every async method or everything that is intercepted, we basically just wrap in another code. So we could, for all of the methods, ultimately get in something like, if you don't want to manually go to each and every method of yours or invocation of a method and do a try-catch block, if I get that right, then you could have this tool do it for you automatically. Cool. It does generate code for you, but I think Castle Core doesn't do it on a source level, but on an IL level. So it's after you compile your code from systems from C# to IL code, then it's mutating your IL code. Where Roslyn generators are early in the pipeline. They are before we go to IL code. They are when we're still compiling C# to IL. So this is all on a Roslyn C# level. So it's very, very early. And the compiler does these interceptions. And basically, well, it's not changing any code, but it's rerouting from one method invocation to another method invocation. And now we're trying to surface them. And we are uncertain why this interceptor location here, it kind of seems to be empty. No, it's not. There we have a location, we have some source span. But do we do something bad in this create method? I suppose. Oops, that's the first. That's the second first. And we get from this location the line span.
The second first.
Sorry.
It's funny.
The second first. Oh yeah, well there's
next time I'm not gonna, like, if I don't win like first place, but second place, I'm just gonna say I'm the second first.
Second first. This file path here is now.
It's not file pathing, or what? Sorry, what's the?
File path is not file pathing now.
Oh yeah, it's still empty.
Which means that if we go to this, where do we create this file path? This would be this one. So is our file path here? But we pass. No, this file path is not. No, this is what terrifies me. Because we pass in the document, our documents have. Oh, is it because we are in unit test? Our documents don't have file paths?
What? No.
Yes.
Really?
Not sure. Because we passed in this file path from.
But didn't we use file paths before? Like, we're just trying to get the same functionality. right?
But because we're here in a unit test, and in this unit test, we may not set up the file paths of these things correctly. So I think maybe if we go to a C# project builder, when we add a new document, we document ID, name, text, folders. Is there a way? Yeah, maybe there's something wrong with our setup here, where we do not set up, because this is not in a unit test, maybe in an integration test, this looks differently. But from our code, it actually looks all right, where we pass in to our syntax walker the document's file path. But maybe these documents that we set up for this unit test, where we use an ad hoc workspace and not an actual MS build-based workspace, we may not set these up correctly. I wouldn't know. Well, there is add document only, where we can add a proper file path. Document ID does not have that. We have a name, we have a text. I wouldn't know how to. Well, maybe because it's not a file-based one. Maybe that's the thing. It doesn't have a file name. It doesn't have a file path because it's not file-based, I think.
But okay, but yeah, this just can you go one thing back?
I'm not sure where I was. Sorry. Yeah.
So fast. Yes. So yeah. So we've got project builder add document, and then just underneath there is this like string file path, path combine, directory path name.
Yeah, because here we say there's another overload. Very good. So we should okay. Where do we get this file path
And
from?
that's why I'm here.
Get the directory path. So we should invoke this method instead. So we pass in some folders. Okay. Okay. So we need to, in our setup, we pass here some folders. That's it. Let's call this interceptor folder and intercepted folder. Yes.
Okay.
Good call. And well, I guess our test expectation is still.
Yep. Well, actually, well, I didn't actually see what came out on the test, but we got the. So we got something, but not the right one.
Where's actually our expectation coming from? Oh, is it because we? Maybe I should fix the expectation. I guess that's it. Because our expectation is expecting this to be in here, but it really isn't. Director separator, it isn't. So.
But it was before,
That's
right?
my bad.
So
okay.
Why was it before?
So where is our interceptor? Our
Yeah.
interceptor. Well, we changed. Why was it not before? Well, I guess we changed some methods that we use. Not sure, but our interceptor is in the interceptor folder, and in interceptor folder dot intercepted.cs. And now we have our interceptor at interceptor folder.
Yep.
Intercept. Oh, that's call site. This is the interceptor. So this is the wrong location.
All right. Good.
No, wait a minute. Intercepted. intercepts. This is our interceptor. Why do we expect? Well, we expect the... No, I'm so confusing myself. This is the interceptor. We expect the interceptor to be in... Okay, we call this intercepted.cs. Maybe this is wrong. This is actually in... This is the... No, wait a minute. Sorry. That's the intercepted. This is actually the intercepted folder. Let's call this intercepted folder, because in the intercepted folder we have the intercepted. And this will be our, let's call it call site folder. And our, oh, wait a minute, because the actual interceptor that is source generated, no, we are using the wrong path here. Because this path really should be something like that was earlier. Should be really this.
Yeah.
Wait a minute, what's now? The actual is interceptor. Because the interceptor is actually what we had earlier.
Yeah.
So I guess I messed this up now. Okay, let's leave it like the location is not 100% correct. Well, the base implementation is working. We do find the interceptor and the intercepted, but now we need to like bring them correctly together. I guess we're now at the 20%, 80% done, 20% that require 80% of the time, kind of a
Correct.
thing.
At least there's no spacing problems. That's usually what gets us.
No spacing problem. Maybe let's just get not yet. Let's just think about the second location, because we now have the intercepted location. Well, I guess we can now actually need to assume that it is in the, so we can now go to our test, because we now changed the expectation. The call site is now in call site folder. And with that, call site folder, but we don't get the I think this is the location of the, because this is not an intercepted location.
Yeah.
Which would be, here is the intercepted. We do get column 1 because we get this entire invocation. Not really this thing.
Okay.
But maybe in our case, because well, we previously had this information really available. We knew exactly from this previous model, we knew exactly this character. Maybe this information isn't that useful after all. Maybe the line where this interception is occurring is sufficient. So that you can browse through, okay, this call is intercepted. Or maybe, could we get to that? Maybe we can actually let's see if we can get the actual, because this would be the intercepted invocation location. Let's for once go to our walker. We get the interceptor method. So we know this one. This is the location of the interception. So this will be our node. So our invocation expression syntax yields the location of the interception. And if we go to our locator, we now use the intercepted.
Yeah.
We get the location. But this is not the invocation, it's the entire invocation, not just the sub part. So not sure if we could get this information out of there. But also maybe it's not that relevant. So I would we would change our, I guess we could change our interceptor locator to be, because now this model of the awareness of that this interception is actually happening after the dot is kind of gone. So if you just say, you know what, navigate to this line, because, well, what we could do is more or less provide a syntax here, like similar like so, that now says, if we go to the test, maybe this would actually be a little bit more helpful. If we want to find out the intercepted, go to call site, :3.
Okay.
Do I want to remove all of that information? Well, we would quite need to change all of the assertions and here and everything. But for an informational perspective, I guess we have the information that we need. Sorry, I interrupted you.
Yeah, no, I guess it's, as you said, like the model has changed, and that's the focus on like the exact, I guess, character is kind of gone. I think it's a little bit sad because, like, if you have a very like a long chained kind of situation, then it could be anywhere, and you don't know which exact method, right?
That's also right. Yeah. Well, I think we should know that. I think we should know the beginning. So if we were to go to our test and add to our original, no, let's call another method, system.console white line, which is not intercepted. I would kind of assume now it's no longer at character 1, but at character, what is that? At character 29 or something similar. So we should get the beginning of the expression rather than the beginning of the invocation. So
so it's at least something.
29. So it's
good enough.
We no longer get the information here, but we get the beginning of this entire expression. Yeah.
Yeah.
So I guess that's close enough.
Close enough. All right.
And with that, I think, well, the only thing that's left is getting this location right. But other than that, we have all the informations we need. We do still find the original interceptor that may be intercepting one or many methods. Let's give that a try. What if we were to intercept, if we have 2 invocations? Do we now get 2 interceptions in the actual? Well, we don't expect it in the expected, but would the actual now still actually show two interceptions? So does this work? And we run into an exception.
Lovely. Well, with that, we're back to like the beginning of the episode with the trivia. We promised you exceptions.
We promised, and here they are.
And we delivered.
So perhaps. Okay, and we have a bug that we can't.
Wonderful.
No, wait a minute. No, we don't, because this is actually a bug of this interceptor. This interceptor cannot create multiple interceptions. It will will fail because we will actually.
Yep.
We kind of will emit this attribute twice. So no, this interceptor is not designed to do multiple interceptions. But let's confirm the opposite. If there is none,
okay,
will it then not fail and show no interceptions? I hope it does. So it's not our interceptor locator that's failing, but the source generator that's part of the test. And here now, it's okay. I'm not sure if this now means no interceptions or nothing was found.
Yeah, okay, so that's also like an optimization that we could do. Oh, well.
Yeah. But we do what we saw earlier. I guess we are 80% correct to what we had earlier. Oops, I should remove the second this invocation as well. We do find the interceptor.
Yep.
We then group it with all of the methods that this interceptor is intercepting and can now extract the information and display this in a nice string at the output that is then maybe via Control T. So we basically then just enter, maybe we have an invocation at, I don't know, program .cs line 1. You just enter this in your IDE, do Control-T, hit enter, and then you come exactly to where this call is intercepted. And well, I guess this is actually the experience that we wanted originally, so that we have a tool that shows you where you don't call the method you thought you called, but actually a source generator created an interceptor that is rerouting now to different methods.
So we've exposed them.
From that perspective, we're good. We just need to reformat this string a little bit, and then I guess this feature would be maybe a little bit more testing, but then this feature would be good to ship.
Yeah. And altogether, like, I guess, I mean, I promised I'd get confused in this episode because of all of the, the namings and the sort of the deep dive into something that I haven't looked at in a year. But all in all, I guess it is still, like, with the changes, it's a lot simpler than what we had, I guess, last year, right? And a lot easier to read. I think if we look at this a year from now with, like, the next version, I think we're gonna need a little less time to catch up because it's not as okay.
I'm not sure if it's, excuse me, I'm not sure if it's me or you, but you're turning quite robot. Your voice is robotic. Excuse me. Sounds like a synthesizer, I'm sorry.
It's exposed me. I'm not actually human.
Yes, I'm afraid you've gone robot. Well, maybe now that's your connectivity or your audio setup to tell us to call it a
Yeah.
Oh. Okay. Okay. Well, I guess the end is a little bit anticlimactic, but where you think you were going at is that it's now way simpler. I think in our locator, we didn't use this method is uncalled, so we basically replaced an entire complexity of this method. This is significantly less, and also for generated authors, it's also quite simple. We don't need to do any of that anymore. We just call this new method, say, give me the string, and that's good. So yeah, both from the author, but also for us as a tooling perspective, code is significantly less, and it's now part of the API, and it's now versioned, and interceptors are now available, and I'm happy, and cool. Then, yes, then when we close the session, next time, we haven't quite determined next time, but we will go into a chat with Stuart to find a replacement date where his internet works and Eva's sound works and my brain works again. Getting really bad. Do you mind muting yourself? Sorry. Yeah, this is a little bit anticlimactic. But yeah, please observe our social media channels. We will post on all of them when we are back together with Stuart to talk about what we originally wanted to do today. So again, sorry for the confusion. Next session, we will talk about what's new in .NET 9 and also what's new in C# 13. And well, today we took a look at one of the parts, the new interceptors that is now a more stable thing. Previously it was dramatically experimental. So we now have interceptors for sure. And yes, thank you everybody very much for watching. Likewise, Eric, thanks. And yes, everything will work next time. We have a promise there, we have a commitment. And yeah, we will be back.